Welcome to this video about an odometer test made by the Geo-Engineering department at TU Delft. Odometer tests are performed by applying an increasing normal load to a soil sample, which is laterally confined, and measuring the vertical deformation response as a function of time. This response is called consolidation. The results from these tests are used to predict how a soil in the field will deform in response to a change in effective stress, such as an applied load by some kind of construction. The odometer test for this practical takes 2 weeks. On the first day, a clay sample will be prepared and loaded. The resulting settlement is measured during the practical day and the 5 subsequent working days. The second lab day, an additional load is applied. The settlement is measured again for 3 working days. On the last working day in this series, the setup is dismantled and the clay sample is placed in the drying oven to determine the water content of the clay sample at the end of the test. The test results can be processed using the log T method and square root T method to determine the consolidation coefficient of the clay for the stress levels applied to the sample. A schematic representation of the setup is shown in the figure. Let's zoom in on the upper part. The sample is constrained by a steel ring with an inner diameter of 65 mm and a height of 20. The top and bottom plates are perforated to allow for two-sided drainage of the sample. The sample is fully submerged in water to ensure saturation during the test. During the test, the sample is loaded from the top and the settlement is measured with a displacement measuring instrument. The first lab day consists of 3 parts: the preparation of the clay sample, the placing of the sample in the test setup, and the loading of the sample. The first part is to prepare the clay sample. Use the calipers to determine the inner diameter of the steel ring. Fill in the average reading on the answer sheet. Again, use the caliper to measure the height of the ring. Lastly, determine the mass of the ring with an accuracy of 0.1 grams. Now it is key to find a fitting test setup. Test whether the ring with the sharp edge facing upward fits around the lower plate. If it did not fit properly in the ring, try another test setup. If it did, take the cylindrical container with you to the table, and now this test setup is reserved for your group. Lubricate the inner side of the ring with Vaseline, such that the wall friction is reduced. Please just use a little bit of Vaseline. When applying too much, the ring will slip off the sample. Using too little, however, will result in the tearing of the sample. Take a sample from the glass container and put it on the working plate. Now use the ring to cut a sample from the clay sample. Gently press the ring with the sharp side downwards over the sample. Use a second ring to insert the first ring into the sample to the desired depth. Leave some excess material sticking out from the top and bottom side. Make sure that the clay inside the ring is not compressed. This will have consequences for the test results. Remove the protruding parts of the sample with a wire saw and flatten both surfaces. Now you will have a sample that completely fits into the ring. Now cut 2 circular pieces of paper to fit the cross section of the sample. To do this, mark the paper on the inside of the ring, so that the paper will not protrude outside the ring. Now apply one of the saturated filter papers on the bottom side. This is the blunt side of the ring. Make sure the filter paper is saturated. The filter paper makes sure that the clay particles don't obstruct the perforated plates. Use the special template to push the ring 2 mm downwards. Trim the excess soil again using the saw. Now take the other side of the template and gently push the ring 1 mm downwards. The soil sample is now pushed inside the ring on both sides. Both the top and bottom plate are positioned 1 mm inside the ring to easily center the ring. The latter is important to prevent loading of the ring rather than the soil sample. Again, apply one of the saturated filter paper pieces on the top side. Determine the mass of soil plus ring. Now the soil sample is ready. The second part is the placing of the sample in the test setup. Thoroughly saturate the bottom perforated plate. Place the sample and ring with the blunt side on this perforated plate. Check if the sample is aligned properly by gently moving the sample. Carefully lower the top plate on the sample without the load frame. Check if the sample and not the steel ring is loaded by feeling if the sharp side of the ring can be felt around the top plate. If necessary, adjust the position by gently sliding the sample. Keep in mind that the sample already experiences some load. Now submerge the sample by filling water in the outer chamber. The water makes sure that the sample always stays saturated. Put the displacement measuring device in place and make sure that the device has enough space to measure. Now that the sample is in place and submerged in water, we can proceed to the third part, the loading of the sample. Start loading the main load frame with a total mass of 10 kilograms. The load frame is first taken from the test setup and no load is applied to the sample yet. Register the load together with the weight of the load frame itself and the weight of the displacement measuring device. Take in mind that the sample is already loaded by the weight of the rod and the displacement measuring device. This initial load is assumed to be similar to the effective stress on the sample location. Register the initial load and the time of load application. Gently put the load frame in place and at the same time press start on the stopwatch. Make sure that the load frame does not swing after it is set in place. Now log the displacement after the given time frames on the assignment. Measure the settlement with an accuracy of 0.001 millimeters. From now on, take a measurement every day for 5 days. Try to log on the same time slot to have the most accurate measurements. And keep the sample saturated by adding water if required. The second lab day consists of only one part, increasing the load. First, we have to log the displacement at the moment. This is the final settlement after the first load step and the first reading for the second load step. Now place 20 kilograms of weights on the bottom frame and hang it on the main load frame to allow approximately 25 kilograms of additional weight to load the sample. Apply the extra load quickly but gently and at the same time press start on the stopwatch again. Again, log the displacement after the given time frames. Log the settlement with an accuracy of 0.001 millimeters. From now on, take a measurement every day for 3 days. Try to log on the same time slot to have the most accurate measurements. Keep the sample saturated and add water if required. After dismantling the setup, the final step is to determine the wet and dry weights of the sample. First, measure the weight of the saturated sample. Next, place the sample in the drying oven. After 24 hours, measure the dry mass of the sample. Now all data is collected. The test results can be processed using the log t and square root t method. And with that, the consolidation coefficient for the sample can be deduced. On behalf of the Department of Geo-Engineering at Delft University of Technology, we thank you for paying attention to this video. Good luck with your studies.